Welcome to the final video of this section. We're going to talk about exponential decay. So the book has all these formulas, but it's all the same stuff. Every single video in this section is covering the same stuff. So for decay, it introduces this new formula. This right here, it's kind of hard to see. This is the Greek letter lambda. Kind of looks like this. And it's known as the decay constant. You might say, oh, it's just like K, the growth constant. And yeah, these are the same formulas, right? The only difference is here, this is going to be a positive exponent, and here it's going to be a negative exponent, okay? So, I mean, there's new formulas, but again, it's all just that C e to the KT. The whole section, C e to the KT, every single thing. It's just sometimes it's a positive exponent, sometimes it's a negative exponent, and we can change letters enough to drive you crazy, okay? But it's all the same formula here. So let's do some problems here. We are going to talk about strontium 90. Any strontium fans out there? Anyone love the element strontium? I think that's how you say it. I have no idea really about anything about strontium, but there it is. This will be example 4. The decay constant for strontium, not strontium, strontium 90 is 0.0244, where T is measured in years. How long will it take a sample decay to half its starting value? So this is similar to that last example with tripling time. Okay. I don't know how much we're starting off with. I don't know how much strontium 90 I have. Maybe I've got 20 kilograms. That's probably a lot. I don't know. Who knows? Question is, how long will it take to get half? So we can use that formula from before if you'd like. E naught, e to the negative lambda, t. And the decay constant is our lambda, right? This is our lambda right here. So we'll just plug that in and say, okay, when are we at half of what we started with? So this right here, this is what we're starting with. And I don't know this amount. But the question is, when is P of t equal to half of that? Again, very similar to the last example. So we'll just plug things in and find out. So P of t, that's the left-hand side. So when is the left-hand side equal to that? Replace it on the left-hand side, 1/2 P naught. When is this equal to the right-hand side? Again, lambda is 0.0244 approximately. We just have to solve for t. So let's see how good your exponential equation solving skills are. These P naughts are going to cancel. We're left with 1/2 equals just e to the negative 0.0244. Take the natural log of both sides. Same steps every time. We'll get that the natural log of 1/2 equals the natural log of the right-hand side. They're inverse functions. We can skip this step by now, I think. Divide both sides by that coefficient. You're going to get t is equal to the natural log of 1/2 over negative 0.0244. So what is this approximately equal to? I've got no clue, but luckily I've my good friend, the calculator. Well, the natural log of 1/2 divided by negative 0.0244. And that's going to be 28. Uh-oh. My Apple Pencil battery is low. That'd be really awkward if it dies. 28.4077. Or about 28.5 years. Okay. This is how long it's going to take. We'll say, okay, about 28.4 years. And that's our final answer. That's how long. It doesn't matter how much we start off with, because it's decaying at a rate proportional to the amount. It doesn't actually matter what the amount was. But it's going to take a little over 28 years for half of our strontium 90 to decay away. This is what's known as a half-life. All right. The half-life is just how long until half decays. We'll use that term every once in a while. Half-life is basically the same thing as doubling time. Doubling time, how long does it take till it doubles? Tripling time, how long does it take until it triples? Half-life, how long does it take until it halves? Okay. And yeah, that's basically exponential decay. I have another video with another example, but it's nothing new. It just uses kind of everything with another longer exponential decay problem. But go ahead and get started if you'd like.